Let's take an example to see how an Avl tree insertions are done and then how the nodes are rotated for balancing of the tree. So suppose these are the keys that we have to insert to create an Avl tree. First is the data value 50, so we will have it as the root node. Then comes 30, so since 30 is less than the root node, we will add it to the left subtree of this root node. What is the balance factor of each node? For this one, it is 0 minus 0. 0 is the height of the left subtree since it is empty, so 0. This is the height of the right subtree, so since again it is empty, so 0 minus 0 is 0. For the root node, the height of the left subtree is 1, this edge, and the height of the right subtree is 0 because it is empty, so it is 1. Since the balance factor is 1 and 0 for the nodes, we say that this is a balanced Avl tree as of now. We know that for the Avl tree, the balance factors can only be -1 or 0 or +1. So we have to take care of this. If the balance factor is something else, then we have to rebalance the tree. Now the next data value that is coming in is 10. We first compare 10 with the root node. So the root node is 50. So that means we have to go left. Then we compare it with the next node, which is 30. Again, since 10 is less than 30, again we have to go left. So the node will be added over here. 10. Now let us compute the balance factor. For this node, since this is a leaf node, it will be 0 minus 0, balance factor is 0. For this node, left subtree height is 1, right subtree height is 0 because it is empty, so 1. For this node, height of left subtree is 2, 1 and 2. Height of right subtree is 0 because it is empty, so it is 2. So this node has become a critical node now. And what kind of an imbalance has been created? Left, left. Because this new node that was added as a left child in the left subtree. So this needs an LL rotation. And how do we perform an LL rotation? By doing a right rotation like this. So when we will do a right rotation, we will have 30 coming at the top, 50 being pulled down and 10 again coming as the left child of 30. Now if you see the balance factor at each node, this is having a balance factor of 0, this is also having a balance factor of 0, and for this node, height of left subtree minus height of right subtree, so 1 minus 1 is 0. So now the tree is balanced. Now let's see which is the next data value which is coming in. It is 40. 40 is larger than 30, so we will go right. It is less than 50, so we will have to add it as a left subchild. So now when 40 has been added as a left child of a node, let's see the balance factors. For this node, this is 0, balance factor is 0. For this node, height of left subtree minus height of right subtree, so this balance factor is 1. For this node, height of left subtree is 1, height of right subtree is 2, so 1 minus 2 is going to give us -1. So this we can say is a balanced Avl tree because each node is having a balance factor of either -1 or 0 or +1. So no rebalancing is required in this case. So what is the next data value coming in, which is 45. So we first check with root node 30, we go right, we compare it with 50. So we know that we have to go left because 45 is less than 50. Now we compare with 40. So since 45 is larger than 40, it will come as the right child of the node 40. Now when 45 has been added as the right child of this node, let us compute the balance factor. So this is having a balance factor 0. This is having a balance factor of 0. For this node, balance factor is 0, minus 1, which is equal to minus 1. For this node, height of left subtree is 2, 1, 2. Height of right subtree is 0, so it is 2. This node has now become the critical node. If you will see at this node also, the height of the left subtree is 1 and the height of right subtree is 3. So this is also minus 2, but we have to first take care of the deepest ancestor, which has become imbalanced. If we can take care of this node, then the upper ancestors, the higher ancestors would also become balanced automatically. For this node now, what kind of an imbalance has been created? This is left and this is right. So an LR imbalance has been created. So we need to do an LR rotation. And how do we do the LR rotation? We will first do a left rotation using these two nodes. So this will go up. So 45 will go up and 40 will come down. After that we will do so it is going to be like this. After the first rotation, it will become this. And then we will do a right rotation. So 45 will go up, 40 will come here and 50 will be brought down. So this is how these three nodes will be handled in an LR rotation. Okay. As I have explained in my earlier videos also, that if three nodes are being handled, always three nodes will be handled in the rotation. Whatever is the median value, after the rotation, the median value will come as the center node and the lower value would come as the left child and the higher value would come as the right child. So now after LR rotation has taken place, how will this AVL tree look now? Now when you will compare the, check the balance factor, this has a balance factor of 0, this also 0. For this node it will be 1 minus 1, so 0. For this node it is 0 and for this node height of left subtree is 1 and now height of right subtree is 2, so minus 1. So we see that the AVL tree is balanced now. Now comes the data value 35. Where will this be added? It is greater than root node, so we have to traverse right, compare it with 45. 35 is less than 45, so we have to go left, compare it with 40. It is less than 40, so now it will be added as a left child of this node at 40. Now if we start comparing the balance factors again. For this node balance factor is 0. For this one, 1 minus 0, which is equal to 1. For this node it is 0. For this node it is height of left subtree, which is 2, minus height of right subtree, which is 1, so 1. For this node it is 0 and for this node it is height of left subtree, which is 1, minus height of right subtree, which is length to the deepest leaf, which is 3. This becomes minus 2. Now we see that this node has become the critical node. And always when we do a rebalancing, the rotation will take place only with three nodes. So with this critical node, the rotation that is going to take place is only with these three nodes. And what kind of a rotation will take place? This is to the right and this is to the left. So this will require an RL rotation. If you see that the median value over here is, we are having 30, 40 and 45. At the end of this rotation, we will have 40 in the center with 30 on one side and 45 on the other side. And what kind of a, how do we take care of an RL rotation? First we will do a right rotation and then we will do a left rotation. So let's see how the AVL tree will look like after this rotation. So when we did the RL rotation for these three nodes, 30, this one, and this one. We first do a right. So 40 will be pulled up and 45 will be pulled down. And then we do a left rotation. So 40 will go up, 30 will go down, and 45 will come here. You can check my earlier videos on how RL rotation is done. Now after this, these three nodes have been taken care of. You can see that 40, which was the median value, which has come in the center. Now we have to take care of the other nodes as well. 10 is the left child of 30. So again it will be added as the left child of 30. 50 was the right child of 45. So 50 would be added as the right child of 45. 35, this new node, was the left child of 40. So if it is the left child of 40, that means we have to go in the left subtree and we compare it with 30. So here it has to be greater than 30. So since 40 is greater than 30, it will be added in the left subtree of 40, but as a right child of this node 30. So this is how the node 35, after insertion of node 35, it has been rebalanced. The tree has been rebalanced, and this is the new tree now. Now the node that has the value that has come in 70. When we compare it with the root node, and then as we traverse the tree, we will find that 70 will be added over here. When 70 is added as a node over here, you will see that this node over here, the balance factor of this node will be height of left subtree, which is 0, minus height of right subtree, which is 2. So this will be minus 2, and now this node will become the critical node. And what kind of an imbalance has been created? An RR imbalance has been created because of the insertion of this new node. And how is the RR imbalance taken care of? We will have to do a left rotation at this node 45. When we do this left rotation, we will see that 50 will be pulled up. So 50 has come here. 45 will be pulled down. So 45 has come here, and 70 will be pulled up again. As you can see, for these three nodes 45, 50 and 70, 50 was the median value and it has come in the center over here. 45 is the left child and 70 is the right child of this node. Now you will see that for this tree, each and every node over here is having a balance factor which is either -1 or 0 or +1. So this again is an Avl tree. It has been rebalanced and we have all the keys that have been added into this tree. Let's take another example, and these are the keys that are to be added. So first we have 10, so which comes as the root node. The balance factor is 0 because there is an empty left subtree and an empty right subtree. Then comes the value 20. So 20, since it is larger than 10, it will come as the right child of this 10. Now if we see the balance factors over here, this node is having a balance factor of 0 and this node over here is having a balance factor of 0 minus 1, which is -1. So the tree is balanced. Next we have a value 30 coming in. Since this is larger than 10 and larger than 20, it will be added over here. And what will be the new balance factors now? For the new node that has been added, the balance factor is 0. For this node, the balance factor is 0 minus 1, which is -1. And for this node over here, the balance factor is 0 minus 2, which is -2. So this node has become the critical node, and now this needs to be rebalanced. And what kind of a rotation would be required? This is an RR imbalance. So this would require a left rotation to make it a balanced tree. After the rotation, this will be the Avl tree. and you can see that the median value again has come in the center. The left subtree and the right subtree is having one node each, and the balance factor of each and every node over here in this tree is currently either -1 or 0 or +1. Now the next value that is coming in is 40. You can see that as we do in the binary search tree, this value 40 would be added over here. When we check the balance factors, this is having a balance factor 0. For this it is 0. For this node it is 0 minus 1, which is -1, and for this node it is 1 minus 2, which is -1 again. So since each and every node is having -1, 0 or +1 balance factor, again this AVL tree is currently balanced. Next value is 50. This value 50 will be added as a node over here. Now what are the balance factors? For this node it is 0. For this node it is 0 minus 1, so it is -1. For this node it is 0 minus 2, so -2. This node has become a critical node now. And what kind of an imbalance has been created? An RR imbalance has been created. So this requires a RR rotation. And what do we do for an RR rotation? We rotate it like this. So what will be the structure of the tree after this RR rotation? You will see that after the RR rotation, 40 has moved up here. The median value you can see has come in the center, 30 has been pulled down, and 50 has also moved up over here. The balance factor, you will see that for each node it is within these values, so it is again a balanced tree. Now the next value that is coming in is 60. 60 will be added as a right child of this node 50. When this happens, you can check that for this particular node, the balance factor is 1 minus 2, which is -1. But for this node over here, the balance factor would be 1 minus the height of the right subtree, which will now become 3. So 1 minus 3 will be -2. So this has become a critical node now. And the rotation needs to be done only for these 3 nodes over here. In rotation, please remember that rotation would be only with these 3 nodes. And what kind of an imbalance is this? This is an RR imbalance. So an RR rotation would be required. When an RR rotation is done using these 3 nodes will be placed like this. 40 has moved up, 20 has been pulled down, and 50 has come as the right child of 40. Now let's take where the other nodes will go. 20 is the left child of 10 is this node 10 is the left child of 20, so it will come as the left child of 20. 60 is the right child of 50, so it will come as a right child of 50, and 30 is the left child of 40. So we have to go left and place this node 30 over here as in the left subtree of this node 40. Now the next node that is coming in is 70. 70 will come as a right child of this node 60. When this happens, if you keep checking the balance factor, this node will have a balance factor of 0. This will have a balance factor of -1. This will have a balance factor of 0 minus 2, which is -2. So this becomes the critical node now. And what kind of an imbalance has been created? An RR imbalance has been created. So now again an RR rotation will be required only with these 3 nodes. So what will be the structure of the AVL tree after rebalancing of these 3 nodes is done? So the RR rotation of these 3 nodes will result in this structure. 60 has been moved up and 50 has been pulled down because we were rotating around this node. So 50 has moved down and 70 has come as the right child of this node 60. Again you see the median value is 60, which has come in the center with the other values on either side of it. Our next value is 45, which is greater than 40, less than 60, less than 50 also. So it will come as a left child of this node 50. The balance factor here is 0, balance factor here is 1, the balance factor here is 2 minus 1, which is again 1. The balance factor at this node is height of left subtree, which is 2, minus height of right subtree, which is 1, 2, 3, which is minus 1. So this is currently balanced, as the balance factor of each and every node over here is within the specified values. Next value is 47. 47 will come as the right child of this node 45. Now what will be the balance factors? This is having 0. This is having 0, minus 1, minus 1. This will have 2 minus 0, which is 2. So this node has now become a critical node. If the height of its left subtree is 2, the height of its right subtree is 0. So this has become a critical node. And what kind of an imbalance is this? This is an LR imbalance, left-right imbalance. So we need to do an LR rotation to take care of this. When the LR rotation takes place, it will be involving only these three nodes. So first there will be a left rotation over here and then a right rotation over here. So again you will see that this will be the structure that will be created. The median value, this is 47, will come over here, 45 will be pulled down and 50 will be pulled down over here. So this will be the structure of the Avl tree after the LR rotation. The next value that is coming in is 55. You will see that 55 will be added as a node over here as the right child of 50. Now if we take the balance factors into account, the balance factor of this node is 0. For this node it is 0 minus 1, so minus 1. For this node over here it is 1 minus 2, so again minus 1. For this node over here, the left subtree is having a height of 1, 2 and 3 and the right subtree is having a height of only 1. So the balance factor is 2. Now this node has become a critical node. And what kind of an imbalance has been created? This is towards the left and this is towards the right. So an LR imbalance has to be created. So an LR rotation will be required concerning only these three nodes. Every time the rotation will be only using three nodes. So what will happen after an LR rotation takes place? First a left rotation with these two nodes and then a right rotation with taking care of the other node 60 as well. Now when an LR rotation is done using these three nodes, 50 has come in the center, which was the median value, 47 has come here and 60 has come here. The left subtree of this root node does not get disturbed. What about this node having value 70? This was the right child of 60, so it still remains the right child of 60. 45 was the left child of 47, so it again remains the left child of 47. This child of node 50, which was 55, this was the right child of node 50. So again we will check the right subtree of this node 50 and we will place this node 55 over here. Now if we check the balance factor of each and every node, again this is, you will see that it is balanced. The next node value that is coming in is 80 and you will see that this 80 will come as a right child of node 70. Now when we start comparing or checking the balance factor, so for this node it is 0, 0. For this node over here it is 0 minus 1, so minus 1. For this node it is 1 minus 2, so minus 1 again. For this node it is 2 minus 3, so minus 1. For this node it is 2 minus 1, 2, 3, 4, which is minus 2. So this node has now become a critical node. So how will we take care of this critical node? What kind of an imbalance has been created? This is towards the right and this again is towards the right because the node was added over here. This new node was added over here. So this is an RR imbalance. And now the rotation will be with these three nodes. Always involve the critical node and the path in which that new node has been inserted. So RR imbalance has been created and these three nodes will now have to be rotated for balancing the tree. When we take care of this RR imbalance by doing an RR rotation, we see that 50 has come as the root node now, 40 has been pulled down. So the left subtree which was initially of 40, it remains the same. 20 is again the left child of 40 and so on. The subtrees of 60, node 60. So 55 is again the left child of node 60 and the right subtree contains node 70 and 80. We only have to take care of these children of 50. The left child was 47. So since this 47 was the left child of node 50, we will move left and we will park this node 47 over here. And 45 was the left child of 47. So it still remains the left child of 47. Now if you see the balance factor of each and every node, again you can see for this it is 0, for this it is minus 1, for this it is 0, for this node it is 1 minus 2, so minus 1, and for this node height of left subtree is 3, height of right subtree is also 3, so this is 0. So now the tree is balanced again. Now comes a new data value which is 75. We will see that it is greater than 70 but less than 80, so it will come as a node over here. When this comes as a node over here, and now we start checking the balance factors again. So when we check the balance factor, we will see that for this particular node, height of left subtree is 0, height of right subtree is 2. So this is minus 2 and this node has become the critical node now. What kind of an imbalance has been created? R, right and left. A right-left RL imbalance has been created, so an RL rotation is required. RL rotation, we know that it is a double rotation. And what all three nodes will be required to be rotated? These three nodes will be rotated. Now when an RL rotation happens and there is a double rotation, first there will be a right rotation. So 75 will be moved up, 80 will come down, and then the left rotation will happen. So now 75 will go up, 70 will come down and 80 will move up. So this will be the new structure of the Avl tree, and you can see again in this case each and every node is balanced. That means it is having a balance factor of either minus 1, 0 or plus 1. Now a new data value is coming which is 72. We will see that this value 72 will be added as a right child of this node which is having a value 70. So let's see the balance factors. This is having a balance factor of 0. This is having a balance factor of 0 minus 1 which is minus 1. This node is having a balance factor of 2 minus 1 which is 1. This node is having a balance factor of 1 minus 1, 2 and 3. So balance factor becomes minus 2. So now this node has become the critical node. It is imbalanced again. And what kind of an imbalance this is? So this node is the critical node. So right and left, because the new node was added in the left subtree. So this has caused an RL imbalance. So an RL rotation will be required. So let's see how this RL rotation will take place and which three nodes will be involved in this. These three nodes will be involved in this rotation. So what will be the structure of the AVL tree? First a right rotation and then a left rotation will take place. So right rotation means this rotation will take place, and after that the left rotation will take place. So what will be the new AVL tree? When these three nodes were rotated, we had an RL rotation. 70 has come here, 60 has been brought down, and 75 has come as a right child. What about 55? 55 was the left child of 60, so it still remains the left child of 60. What about 80? 80 was the right child of 75, so it still remains the right child of 75. What about 72? 72 was the right child of 70. So we have to go in the right subtree of 70 and put this 72 over here. Again we see that each and every node in the tree is balanced, and this is a balanced tree. So the AVL tree has been balanced. The next value that is coming in is 5. 5 you will see will be added as a left child of this node 10. If we see the balance factors, this is having a balance factor of 0. This will have a balance factor of 1 minus 0, which will be 1. This node will have a balance factor of 2 minus 1, so 1. This will have a balance factor of 1, 2, 3 minus 2, 3 minus 2, so again 1. This will have a balance factor of 1, 2, 3, 4 minus 3, so it is also 1. So currently the tree is balanced. Now we are having the next value which is coming in, which is 2. This will be added as a left child of this node 5. Now what will be the balance factors? This is having a balance factor of 0. This node is having a factor of 1 minus 0, 1. This node over here is having a balance factor of 2 minus 0, so 2. This node 10 has become the critical node now. And what kind of an imbalance this is? Left, left. So this is an LL imbalance. So an LL rotation is required to balance this AVL tree. When the LL rotation is done, it will be done using these three nodes. And what will happen? It will be a right rotation which will take place, and this 5 will move up and 10 will be brought down. So this will be the new structure. 5 has come over here, 10 has been brought down, and 2 is as the left child of 5. Again now you will see that each and every node in this tree is balanced. So no other rotation is required. Now the next value that is coming in is 15. 15 will come as a right child of this node at 10. Now let us see the balance factors. This is having a balance factor 0. This is having a balance factor of 0 minus 1, so minus 1. This is having a balance factor of 1 minus 2, so minus 1. This is having a balance factor of 1, 2, 3 minus 1, which is 2. So this node over here has now become the critical node. And what kind of an imbalance this is? LR. LR imbalance has happened. So an LR rotation will be required, and it will be done using these three nodes. So what will be the new structure of the AVL tree? So when an LR rotation is done using these three nodes, 10 will come here in place of 20. 20 will move down and 5 will be the left child of 10. Let's take a look at the other nodes. 30 was the right child of 20, so it remains the right child of 20. 2 was the left child of 5, so 2 is the left child of 5 again. 15 was the right child of 10. So here is 10 and we have to go in the right subtree of 10. So 15 will come here. 15 will be parked over here. Now again we will see the balance factors and we will see that the tree is balanced again. The last data value that is coming in is 35. We will see that 35 will come as the right child of this data value 30. What will happen when it comes here? This is having a balance factor of 0. This will have a balance factor of -1, 0. This node over here will have a balance factor of 1, -2, which will be -1. This node will have a balance factor of 2, -3, so -1. This node over here will have a balance factor of 1, 2, 3, 4 minus the right subtree is only 2. So 2. So this has become the critical node now. Because of the insertion of this data value, this node has become critical node. And what kind of an imbalance this is? Left and right. So an LR imbalance has taken place and a rotation will be required using these 3 nodes only, starting from the critical node. So what will happen in the LR rotation? First a left rotation and then a right one. So let's see how the tree will look like. When an LR rotation takes place with the nodes having values 40, 10 and 20, this will be the position. 20 will come here, 40 will come here and 10 will be here. Now we have to take care of the rest of the nodes. 47 is the right child of 40, so 47 will come here, and 45 is the left child of 47, so 45 will come here. What about this node 5 and 2? They are in the left subtree of node 10, so 5 and 2 will come here. Now we have to take care of this node having a value 15. So this is in the left subtree of 20. So that means we have to go in the left subtree of 20. So this 15 will come here. What about this nodes 30 and 35? They are in the right. So node first we'll take node 30. It is in the right subtree of 20. It is in the right child of 20. So we will go here and here we will have this node 30 in the right subtree of 20. What about 35? 35 is the right child of node 30. So just a second. So it will become the right child of node at 30. So this is how all the nodes will be taken care of. And again, if you will see the balance factor, if you see for this node it is 0, for this node it is 1 minus 0, so 1. For this node over here it is 2 minus 1, so 1. For this node now it is 1, 2, 3 and 1, 2, 3, so it is 0. For the root node it is 1, 2, 3, 4 left subtree and 1, 2, 3 is the right subtree, so 1. And similarly you can check for each and every node that the balance factors are either -1 or 0 or +1. So this is a balanced Avl tree and all the data values have been inserted. So this is how you take care of the rotations as and when the insertions are happening with the new data values.